Find the solution set of the following linear inequations graphically. Okay, let us begin. Now for our first task will be to convert each of the linear inequation into equation. So starting with the first inequation, we have x minus y less than or equals to 1. Now what we'll do, we will replace this inequality symbol with an equality symbol such that we get x minus y equals to 1. So we now have a linear equation in two variables. Similarly, coming to the second inequality, we have x plus 2y less than or equals to 8. So here what we'll do, we will convert it into a linear equation. So we have x plus 2y equals to 8. The third inequality, 2x plus y greater than or equals to 2. So converting it to an equation gives us 2x plus y equals to 2. And then we have x greater than equals to 0. So this will become x equals to 0. Y greater than or equals to 0. That's going to give us y equals to 0. The reason why we converted into all these inequalities into equation, because we are going to plot the graph of each of the equation. So let's go to a graphing calculator. We're going to use Desmos here. So first we will begin by plotting x minus y equals to 1. We have x minus y equals to 1. Okay, next we are going to sketch the graph of x plus 2y equals to 8. We have x plus 2y equals to 8. Next we have the third equation, 2x plus y equals to 2. We have 2x plus y equals to 2. Then we have x equals to 0 and we have y equals to 0. Okay, so let's look at the graph. So here we have all the graph plotted. Okay, so let's consider the graph of x minus y equals to 1. So this is represented by the green color here. So we have x minus y equals to 1. Now this particular line divides the xy plane into two regions. One region is going to lie above the line, so we can call it region number 1, and the other region is going to be below the line, which we can call as region number 2. Okay, now coming to the inequality, so we need to check which region satisfies the inequality x minus y less than or equals to 1. So that means what we'll do, we're going to choose the point of origin O 0, 0, where we have x value equals to 0 and the y value equals to 0 as well. We're going to substitute this value into a linear inequality. So we get 0 minus 0 less than or equals to 1, which gives us 0 less than or equals to 1. Now we need to check whether if it is a true statement or not. Yes, that's indeed a true statement. 0 is less than 1. This tells us that the region that contains the origin is going to be a solution to the given linear inequality. In other words, this is our point of origin. So here, the region above the green line, that is going to be a solution to our given linear inequality. Fine. So what we can do, we can check out the graph. So here we need x minus y less than or equals to 1. So what we'll do, we're going to replace the equality symbol back to its inequality when less than or equals to 1. So clearly we can observe here that the region above the green line, that means x minus y equals to 1, this is going to be the solution of the given linear inequality. Similarly, we can come to the next inequality. So here we have x plus 2y less than or equals to 8. So here also we can use the same coordinate value 0, 0. So we get 0 plus 2 times 0 less than or equals to 8. We get 0 less than or equals to 8. That is also a true statement. That means the region containing the origin 0, 0 is going to be a part of the solution. Let's go to our graph. So here we have x plus 2y, which is denoted by the purple line. So it's going to be lying below. So here we have the origin point. So this point is going to be included in the region below the purple line. So let's check that out. So likewise, we're going to change the equation to an inequality. We need x plus 2y less than or equals to 8. As we can see here, so the region which includes the origin is going to be the solution to x plus 2y less than equals to 8. Okay, coming to the third one, so here we need 2x plus y greater than or equals to 2. So we need to change the equality sign to greater than or equals to 2. Okay, fine. So here we have, so here as we can see, for the line 2x plus y equals to 2, which is represented here by the black colored line. Now this is not including the origin 0 comma 0. So we can verify that. So here if we choose 0 comma 0 and substitute into our inequality, we have 2 times 0 plus 0 greater than or equals to 2, which gives us 0 greater than or equals to 2. We know that this is an incorrect statement. That's why when you look at the graph, the origin is not a part of the solution. The solution lies above the line 2x plus y equals to 2. Next we have x greater than or equals to 0. So we can change it to greater than or equals to 0. So this is going to lie to the right of the y-axis, and then y greater than or equals to 0. So as you can see here, it's going to lie above the y-axis. It looks very cluttered, but if we try to find out the common region, so that's going to be this particular region. This is going to be the solution set. So any point that we pick up from this particular region, this is going to satisfy all of the 5 inequalities.